We have been talking about probability. Remember that the probability of an outcome of a random event is related to the proportion of times the outcome would occur if the event was repeated many, many times. Now there are particular rules of probability. In fact, there are many more than I'm going to present, but these are some of the basic rules that you should know because they're what we're going to need in the future. These apply to all probability calculations. Just like proportion, probability is always between 0 and 1. That should make good sense since we have related probability to proportions when we repeat events over and over again. A probability of 0 means the event will not happen, just like a proportion of 0 means that there's the absence of that particular category. A probability of 1 means the event will certainly happen, just like when there's a particular category in which we have 100% in that category, the proportion is 1. So as an example of something you'll see more frequently than the 0 and 1, and that is something in between, if 25% of the sampling frame consists of freshmen, the probability of selecting a freshman is 0.25 or 25%. So every time we make a random draw from our sampling frame, there's a 25% chance that we will obtain a freshman. Now, I'm ignoring here the fact that if we take out a freshman from our sampling frame and leave them out, that changes the proportion. So what I'm referring to here is what we call sampling with replacement. That is, you sample, then you put them back, and then you sample again. And in doing so, the probability stays the same throughout our random draws. The same would be true if we have a very, very, very large population and sample without replacement. We don't expect the proportion to change much because the population is so large. Recall that when we sampled, we did not always get 25% freshmen. Sometimes we got less, sometimes we got more. But nonetheless, the probability stays consistent at 25% based upon the original population proportion. The sum of the probabilities of all possible outcomes is 1. So if we have 25% freshmen, 25% sophomores, 30% juniors, and 20% seniors, notice that these proportions, 0.25, 0.25, 0.30, 0.20, add up to 1, which is the same as 100%. That is, we have 4 events here, and we are not sure which event's going to take place, but we know that one of those 4 events will take place. And therefore, there's a 100% chance that we'll get either a freshman, sophomore, junior, or senior, which is why these proportions or probabilities add up to 1. The probability that an event will not occur is 1 minus the probability that the event will occur. So if there's a 25% chance of selecting a freshman, that means there's a 1 minus 0.25 or 0.75 or 75% chance of selecting someone other than a freshman, that is, a sophomore, junior, or senior. Now, if 2 events have no outcomes in common, then the probability of one or the other of these 2 events occurring is the sum of their individual probabilities. Well, what about the probability of selecting a freshman and the probability of selecting a junior? If you make a random selection, does the selection of a freshman have anything in common with the selection of a junior? That is, can they occur at the same time? No, they cannot. You either select a freshman or a junior, not both, because no one in our sample is both a freshman and a junior. They are what we call mutually exclusive. So since they're mutually exclusive, that is, you can't have both at the same time, then the probability of selecting either a freshman or a junior, one or the other, is simply found by adding up their individual probabilities. So if the probability is 25% and 30%, I add up 0.25 plus 0.30. That gives me 5.55 or 55%. Thus, I can say the probability of selecting either a freshman or a junior is 55%. If two events are independent, the probability that both events will occur together is the product of their individual probabilities. By independent, what we mean is that one event does not influence another. So let's suppose I take two random samples, each time with replacement. If I take a random sampling of a single unit, then replace that unit and do it again, these are independent events. What happens the first time does not influence what will happen the second time. So because they're independent events, I can solve a problem like this one. What would be the probability of making two draws and both times selecting a freshman? Well, if the probability of selecting a freshman is 25%, then to find this probability of selecting two freshmen, I just take 0.25 times 0.25, which is 0.0625 or 6.25%. That tells me that if I take two randomly sampled units, the probability that will both be freshmen is 6.25%. So those are the basic rules of probability that you'll need to know, and we'll use those rules in the future as part of our research.